Hi everyone, welcome to Echo Learning Classes. This is Professor Geeta Mahesh. Dear students, let us discuss the most important and interesting concept, that is ordinal utility analysis. As earlier we discussed, there are two approaches to study consumer behavior. One is cardinal utility analysis, another one is ordinal utility analysis. According to cardinal utility analysis, utility can be measured in terms of cardinal numbers like 1, 2, 3 and so on. Professor J.R. Hicks criticized cardinal utility analysis because utility is a subjective concept and utility cannot be measured in cardinal numbers. After criticizing cardinal utility analysis, he has developed ordinal utility analysis where utility can be compared but it cannot be measured, and it can be compared on the basis of taste and preference of the consumer by assigning ranks or preferences like first preference, second preference, third preference, etc. Dear students, before we take up a main concept, let us understand this concept with an example by making assumption that utility can be measured in cardinal numbers. Later we will discuss without that assumption. Let us assume there is a consumer who is having an income equivalent to rupees 200 and the price of banana is 5 and the price of mango is equal to 10 rupees. And the utility derived from each banana is equal to 10 utils and the utility derived from mango is equal to 20 utils. Now consumer has to spend his 200 rupees on banana and mango in such a way that he should maximize his total utility. Let us assume that the consumer wanted to have 24 units of banana and 8 units of mango. The money spent on banana is equal to 120 and the money spent on mango is equal to 80. So which is equal to 200. If we calculate the utility derived, then from 24 bananas he can derive 240 units of utility and from mangoes he can derive the utility that is 160, which is equal to, together if you consider, which is equal to 400. Assume that in the shop the number of bananas is less. So he has to make a fresh combination. While he is making or choosing a fresh combination according to his preference, he has to spend his 200 rupees in such a way that he has to get a maximum utility that is equivalent to 400. Now he makes a fresh combination of 16 bananas and 12 mangoes. If you consider 16 bananas means the money spent on this will be 80 and on mangoes he is going to spend around 120, which will be equal to 200. The utility if we calculate, it will be equal to 400, that is from bananas is going to get a 160 and from mangoes is going to derive 240. Similarly, he can make another combination, that is C combination, with 8 bananas and 16 mangoes. And if we calculate, again the money spent on both will be equal to 200 and from that combination too he is able to derive 400 units of utility. By observing this, you can say that from all the combination A, B, C will give same level of satisfaction. Now, the consumer is indifferent, is not differentiating between these combinations. because he is giving a equal importance for all the combinations. Any combination is okay for him because all the combinations are giving a same level of satisfaction, that is A is equal to B is equal to C is equal to 400 units of utility. So he is indifferent to any of this combination because each combination will give him a 400 units of utility. So, utility or indifference curve is trying to explain us the consumer's demand and preference patterns. Now, let us start with the meaning of indifference set. It is a set of all possible combination of two goods which gives equal or same level of satisfaction. If we represent this set of all possible combination of two goods which gives the same level of satisfaction, then you will get an indifference curve. So, indifference curve is a locus of all those points representing various combinations of two goods giving a same level of satisfaction to the consumer. As already we discussed, the combination A, B, C, when you represent on a graph, all these combinations lies on an indifference curve. So this represents that each combination will give a same level of satisfaction. The combination A, combination B, combination C will give a same level of satisfaction. This we call indifference curve. An indifference curve shows all those combination of two goods which gives the same level of satisfaction. Now let us understand with the help of a indifference schedule. Indifference schedule shows the combination of different combination of cups of tea and biscuits. So you can see combination A, 1 cup of tea and 12 biscuits. Combination B, 2 cups of tea and 8 biscuits. Combination C, 3 cups of tea and 5 biscuits. Combination D, 4 cups of tea and 3 biscuits. And combination E, 5 cups of tea and 2 biscuits. All these combinations are giving a same level of satisfaction according to a particular consumer's preference. Now let us understand with the help of diagram. When these combinations are represented on a graph by taking cups of tea on x-axis and biscuits on y-axis. You can see when it is represented, combination A shows 1 cup of tea and 12 biscuits. Combination B you can see 2 cups of tea and 8 units of biscuits, and combination C you can see 3 units of or 3 cup of tea and you can see 5 units of biscuits. Similarly, you can see point D where 4 cups of tea and 3 units of biscuits, and point E shows 5 units of or 5 cups of tea and 2 units of biscuits. The indifference curve, you can see it is convex to the origin, and it has a downward slope, or it is flowing from left to right downwards. Why indifference curve is convex to the origin or has downward slope? Let us understand with the help of diminishing marginal rate of substitution. Before we discuss diminishing marginal rate of substitution, let us understand what is marginal rate of substitution. The rate at which one commodity is sacrificed to gain additional unit of another commodity is called as marginal rate of substitution. The short form for marginal rate of substitution is MRS. You can see in this schedule there are different combinations. In this combination, when consumer is moving from combination A to B to have one more additional unit of tea, is sacrificing 4 units of biscuits. When he is moving from B to C to have one more additional unit of tea, is sacrificing 3 units of biscuits. So when he is moving from C combination to D combination to have one more additional unit of tea, how much he is sacrificing? 2 units. This 2 units we call it as the rate. He is sacrificing 2 units of biscuits to have one more additional unit of tea. We call it as marginal rate of substitution. When he moves from D to E to have one more additional unit of tea, he will sacrifice 1 unit of biscuits. Then what do you mean by diminishing marginal rate of substitution? Dear students, just observe this one. Beginning to have 1 unit of tea is sacrificed 4 units of biscuits. To have one more unit of tea is sacrificed 3 units. Observe this one. 4 units, then 3 units. To have one more additional unit of tea is sacrificed 2 units of biscuits. Each time to have additional unit of tea is sacrificing biscuits, but each time the sacrificed number of biscuits is keep on diminishing. This is the reason why we call the indifference curve is convex to the origin or downward slope, or it is a diminishing marginal rate of substitution. If a consumer wants to be on same indifference curve, or he has to get a same level of satisfaction, he can derive same level of satisfaction when he is increasing one commodity by sacrificing or at the rate of sacrificing another commodity. But he is sacrificing each time is keep on decreasing. Now what do you mean by diminishing marginal rate of substitution? Means consumer is always willing to sacrifice lesser and lesser unit of biscuits to have additional unit of tea is called as diminishing marginal rate of substitution. Now there may be a question, why it is diminishing? Why the marginal rate of substitution should be decreasing or diminishing? Again, this depends on law of diminishing marginal utility. When you have less of tea, then the utility from tea is maximum. When you have more quantity of biscuits, that time utility from biscuits will be minimum. When utility is less, when you have maximum, that time you are ready to sacrifice more units of biscuit to have additional unit of tea where you have less amount of tea. As the units of tea increases, utility from tea is going to decrease. Utility from tea is going to decrease as amount of tea increases. In the similar manner, When the unit of biscuits decreases, the amount of biscuits or quantity of biscuits decreases, then the utility from biscuits are going to increase. So when the biscuits decreases, quantity of biscuit decreases, that time your preference to exchange or sacrifice to gain additional unit of tea will be less. So you are ready to sacrifice lesser and lesser unit of biscuits to have additional unit of tea. That is the reason the indifference curve slopes downwards. You can see this makla. Diagrammatically you can see these triangles. Each time, see, beginning is ready to sacrifice this much quantity of biscuits to have additional unit of x. Again, to have additional unit of x is sacrificing y, but the sacrifice is very less. You can measure this one. Here it is 4 is sacrificed, here is sacrificing 3, and here is sacrificing 2 to have one more unit of x commodity. And here you can see this one, it is one biscuit is going to sacrifice to have additional unit of x commodity. Because of this reason, indifference curve is convex to the origin and it has a downward slope. Dear students, you can make use of this notes. Next topic, indifference map. Dear students, if you like, please like, share and subscribe to my channel. Thank you very much.